All right, so get this.
Okay.
We're going to dive into AI that learns like we do.
Right.
Not just, crunching numbers,
Right.
but actually remembering the important stuff
Mm-hmm.
and then using it in new situations, even when there's just tons of information flying around.
Yeah.
That's Titans, this new deep learning model that's got everybody buzzing.
Right.
We've got a research paper here laying it all out.
Yep.
And let me tell you, it's pretty wild.
Yeah. The really cool thing about Titans is how they tackle this huge problem in AI.
But, yeah.
Memory. You see, even those super powerful AI models like Transformers,
Uh-huh.
they kind of hit a wall when they're faced with massive amounts of data.
Right.
Imagine trying to remember every single detail of every book you've ever read.
Oh, gosh.
It would make your brain melt.
Yeah, that's a lot.
Yeah.
So our brains have different ways of handling memories, right?
Right.
Like, I can remember a phone number long enough to dial it,
Uh-huh.
but remembering what I had for dinner 3 nights ago,
Yeah.
forget it. Are Titans working with something similar to that?
They are.
Uh,
They have these separate memory modules, one for short-term stuff like that phone number,
okay.
and another for long-term knowledge like
Okay.
the rules of grammar or historical facts.
So it's like having a mental filing cabinet
It is.
where you store different types of information
Yeah.
for easy access.
Exact.
So no more AI brain melt.
No more brain melt.
But here's the thing that really blew my mind.
Okay.
These Titans, they learn by being surprised.
Yeah.
Like the more unexpected something is, the more they remember it.
That's right.
Really?
Yeah, it's like when you have a shocking experience,
Okay.
you're more likely to remember it vividly.
Right.
The researchers figured out how to measure this surprise in the AI's learning process.
Okay.
They use something called the gradient,
Uh-huh.
which basically tells them how much the AI's expectations were thrown off by new information.
Interesting.
So the bigger the surprise,
Okay.
the steeper the gradient.
Uh-huh.
And the more likely that information is going to stick around in that long-term memory bank.
So hold on.
Yeah.
Are we talking about AI that has feelings now?
Not exactly feelings in the way we experience them,
Okay.
but it's a way for the AI to prioritize information.
Interesting.
Think of it like this.
Okay.
If you're reading a textbook and everything is familiar,
Yeah.
you might just skim over it.
Right.
But if you come across something that completely contradicts what you thought you knew,
Yeah.
you'd probably stop and pay close attention.
Right.
That's kind of what the AI is doing with the gradient,
Okay.
using it to highlight the most important
Uh-huh.
and unexpected bits of information.
That's super clever.
Yeah.
But if the AI keeps stuffing its memory full of surprising things,
Right.
doesn't it run out of space eventually?
That's a good question.
Like my brain definitely can't handle too much new information at once.
Yeah, that's where things get even more interesting.
Okay.
Titans are designed with a forgetting mechanism. It's not random forgetting, though.
Okay.
It's like a super smart filter
Uh-huh.
that decides what information is worth keeping
Okay.
based on how relevant and useful it's been lately.
So it was kind of like clearing out your closet.
Exactly.
You get rid of the clothes you never wear anymore
Right.
to make room for new stuff.
Yeah.
But then how does the AI hold on to the essential knowledge it needs for different tasks?
Right.
Like it can't just forget everything it's learned about language
Uh-huh.
if it's suddenly asked to analyze a math problem, right?
Exactly. And for that, there's something called persistent memory.
Persistent memory.
Yeah, it's separate from the main memory bank.
Okay.
And it stores knowledge that's fundamental to a lot of different tasks.
Uh-huh.
Think of it like basic logic skills.
Okay.
Or understanding the concept of cause and effect.
So this knowledge stays put
Yes.
no matter what specific task the AI is tackling.
Exactly.
So it's like giving the AI a basic toolkit
It is.
that it can always rely on no matter what project it's working on.
Yeah.
That makes a lot of sense.
Yeah.
But hold on. We're talking about different types of memory here, right?
Right.
Short-term, long-term.
Uh-huh.
And then there's that persistent memory we talked about earlier.
Right.
How does the AI actually juggle all of this?
Right.
I mean, our brains are pretty good at that.
Yeah.
But it's still a mystery how it all works.
Yeah, and that's what's so fascinating about this research.
Okay.
They've actually come up with 3 different versions of Titans,
Okay.
each with a unique way of using these memory modules.
Okay.
They're calling them memory as context,
Okay.
gated memory,
Uh-huh.
and memory as a layer.
Okay, I'm intrigued. Let's break down those 3 Titan variations
Yeah.
and see what makes them tick.
Let's start with memory as context, or NA. With AI, uses both the information it's currently processing
Okay.
and relevant memories from its long-term storage
Okay.
to understand the situation.
So it's like, if I'm reading a mystery novel,
Uh-huh.
and trying to figure out who the culprit is,
Right.
I might think back to clues I read earlier in the book,
Yeah.
or even recall similar mysteries I've read before.
Right.
So McA is doing something similar, right?
Exactly.
Pulling those relevant memories
Yeah.
to make sense of the current puzzle.
It's like the AI is having those aha moments
Uh-huh.
where it connects the dots
Right.
between past experiences and
Yeah.
what's happening right now.
Okay, now gated memory, or MAG,
Yes.
that's a bit different, right?
It is a bit different.
Okay.
It's like having a spotlight that focuses on the most recent information
Okay.
while also having access to the vast library of long-term memories.
Got it.
It uses a special gate to control how much influence each memory source has on its understanding.
Okay, so it's like having both a zoomed-in view
Uh-huh.
and the big picture perspective.
Right.
And the AI decides which one is more important at any given moment. That's pretty slick. Now, what about the third one? Memory as a layer.
With memory as a layer, or MAL,
Mal.
the long-term memory acts like a filter processing information before it even reaches the other parts of the AI system.
So it's like having a personal assistant
Uh-huh.
who pre-reads your emails
Right.
and highlights the most important ones.
Yeah,
So you don't get bogged down with all the spam and irrelevant stuff.
exactly. It helps the AI focus on the most crucial information
Right.
and filter out the noise,
Wow.
making it more efficient and accurate in its decision-making.
Wow. These three Titan variations are really pushing the boundaries of AI.
Yeah.
It's incredible to see how the researchers are taking inspiration from the way our own brains work
Uh-huh.
to create these incredibly powerful and adaptable systems.
And that's really just the tip of the iceberg.
Oh, really?
We haven't even touched on how these titans actually perform in real-world tasks yet.
Okay.
Let me tell you, the results are pretty mind-blowing.
Okay, you've definitely got my attention. Let's dive into those results. All right, and see what these memory masters are capable of.
Let's do it. You know, it's fascinating how they trained these titans to be such memory whizzes.
Yeah.
They focused on something called associative memory,
Okay.
which is based on the idea that we learn by making connections between things.
Right, like how I remember someone's name.
Exactly.
I associate it with their face.
Uh-huh. They feed the AI tons of these linked pairs of information,
Okay.
like words and their definitions or images and their labels.
So making those connections.
Right. And the AI's job is to figure out how to store these connections
Right.
and then pull them back up when it needs them.
Got it. So if I show the AI a picture of a dog,
Uh-huh.
it should be able to say, hey, that's a dog,
Right.
because it remembers that connection.
Exactly.
But how does the whole surprise thing work in the training?
Okay.
Does the AI get like a gold star when it makes the right connection?
Well, not quite a gold star, but remember that gradient we talked about?
Yeah.
It plays a crucial role here. During training, the AI is constantly adjusting its inner workings to make more accurate connections.
Right.
When it comes across a link that's really unexpected,
Yeah.
that gradient spikes.
So it's like the AI is saying, whoa, I didn't see that coming.
Exactly.
And that makes it pay extra attention
Right.
and really lock that connection into its memory.
It's all about highlighting those surprising connections.
Oh, okay.
The ones that challenge the AI's current understanding.
Right.
That's how it learns to prioritize the most important information.
This is reminding me of those brain training games
Mm-hmm.
that are supposed to help you remember things better.
Right.
But I always get bored after like 5 minutes.
Yeah.
Surely training an AI like this must take ages, right?
You'd think so, but they've gotten pretty clever about speeding up the process.
Oh, really?
They use the parallel processing power of modern computers,
Yeah.
basically training the AI on multiple pieces of information at the same time.
So like having a whole team of AI trainers
Right.
working in parallel, that's pretty efficient.
It is, and they also revamped the math behind the training,
Okay.
making it super fast on the specialized hardware that AI loves.
So they're not just making the AI smart,
Right.
they're making the training process smart too.
Exactly.
But we're talking about a lot of memory here.
Right. Okay.
Short-term, long-term.
Mm-hmm.
And then there's that persistent memory we talked about earlier.
Right.
How do they decide what goes in that persistent memory bank?
That's a good question.
It's not like there's a universal instruction manual for intelligence.
Right. There's no single manual, but they took inspiration from a bunch of fields.
Okay.
Neuroscience, linguistics, you name it.
Oh.
They focused on knowledge that's essential across different tasks,
Uh-huh.
like basic logic,
Okay.
understanding cause and effect and rules of language.
So it's like giving the AI a foundation to build on,
It's exact.
a set of core principles that it can then apply to all sorts of different challenges.
It's like having a mental toolkit with all the essentials ready to go.
But wouldn't that bias the AI towards certain ways of thinking? I mean, if it's always starting with the same basic knowledge,
Right.
wouldn't it limit its ability to explore new ideas?
That's a great question, and it's something the researchers thought about carefully.
Okay.
They found that by adding these core principles to the AI's persistent memory, they could actually make it less biased toward the order in which it learns things.
Wait, so having this foundational knowledge actually makes the AI more open-minded?
It does.
How does that work?
Well, imagine you're learning a new language.
Okay.
If you already have a strong grasp of grammar from your native language, it can make it easier to understand the structure of the new language.
Right.
You're not starting from scratch.
Yeah.
And you're less likely to be thrown off by unfamiliar sentence structures.
So this persistent memory acts like a mental framework
It does.
that helps the AI organize and interpret new information in a more balanced way.
Exactly. It's like giving the AI a head start, allowing it to approach new challenges with a broader perspective.
Yeah.
And that leads to some pretty impressive results.
Okay, enough with the theory.
Right.
Let's get to the good stuff. How do these titans actually perform in the real world?
Okay.
Are they living up to the hype?
They definitely are.
Okay, good.
The researchers put them through a gauntlet of tests, comparing them to some of the leading AI models out there.
Bring on the AI Olympics.
Exactly.
What kind of events do they compete in?
Well, first up was language modeling,
Okay.
which basically tests how well an AI understands and generates human-like text.
Got it.
They use standard benchmarks like Wikitext and Lambda,
Okay.
which are designed to challenge the AI's grasp of grammar vocabulary and even long-range dependencies in language.
So like trying to predict the next word in a sentence, writing a coherent paragraph, maybe even composing a poem.
Exactly. That's some serious language gymnastics.
It is.
And the results were pretty remarkable.
Okay.
The Titans, especially the MAEG and MAG variants,
consistently outperformed traditional transformers and other state-of-the-art models.
Wow.
They achieved lower perplexity scores,
Okay.
which basically means they were better at predicting the next word in a sequence.
So lower perplexity equals a better understanding of language.
It does.
Sounds like these Titans are pretty fluent.
They are.
But language is just one aspect of intelligence, right?
Right.
What about common sense? That's something that AI has traditionally struggled with.
It has.
Did they test the Titans on that?
They did. They used a bunch of different tests.
Okay.
Designed to challenge an AI's ability to understand everyday situations, social cues, and even subtle humor.
So these tests are like asking the AI to solve riddles, interpret a sarcastic comment,
right,
or understand why a certain joke is funny.
Exactly.
Okay.
And you know what?
What?
The Titans, especially the MAC and MAG versions, consistently scored higher than traditional AI models.
It seems they've got a pretty good grasp of common sense.
Really?
Which is a pretty big deal in the world of AI.
That's huge.
Yeah.
Okay. I'm seeing a pattern here.
Okay.
These Titans seem to excel at tasks that require both deep memory and sophisticated reasoning skills.
I do.
But what about those needle-in-a-haystack challenges we talked about earlier?
Right.
The ones where the AI has to find a specific piece of information buried in a mountain of data?
That's where things get really exciting.
Okay.
They used a benchmark called Babylon, which is specifically designed to push the limits of AI memory and reasoning.
Got it.
The tasks involve finding specific facts or answering complex questions based on documents that can be millions of words long.
Whoa, that's like asking the AI to write a research paper based on an entire library of books.
It is.
Did the Titans survive the data deluge?
Not only did they survive, they thrived.
No.
They blew the competition out of the water, even outperforming some of the biggest and most advanced language models out there.
Like what?
Like GPT-4 and Llama.
Hold on, they outperformed those AI behemoths.
They did.
How is that even possible?
Well,
those models have billions of parameters.
It's a testament to the power of the Titan architecture,
Okay.
even with limited memory capacity. Titans are incredibly efficient at sifting through information
Right.
and zeroing in on what's important.
So it's not just about how much information they can store.
Right.
It's about how effectively they can use it.
Exactly. They're like master detectives of data.
They are.
Yeah.
But all this impressive performance, it's got to come at a cost, right?
That's what's so surprising. They actually achieved these amazing results with significantly fewer parameters than those giant models.
Really?
Which means they're more efficient in terms of both memory and processing power.
So they're not just smarter.
Right.
They're leaner and faster, too.
Exactly.
Now, that's what I call impressive.
Yeah.
But if they're so good, why haven't we heard more about them? Is there a catch?
Well, like any new technology, there's always room for improvement.
Right.
Titans are still in their early stages of development.
Okay.
And their researchers are already exploring ways to make them even better.
So they're like rising stars with a lot of potential, but still some growing to do.
Yeah.
That makes sense.
Yeah.
But, you know, we've been talking a lot about how these Titans learn through surprise.
Right.
But I'm still a bit fuzzy on how that surprise is actually measured.
Okay.
Is it like the AI has a little surprise meter that goes off?
It's a bit more sophisticated than that.
Okay.
They use a mathematical concept called the gradient of the neural network.
Right.
It's a way to measure how much the AI's expectations are deviating from reality.
Okay. I remember we touched on that earlier, but could you give me a visual for that?
Sure.
I'm a much better learner when I can picture things in my mind.
Okay, imagine a vast landscape with hills and valleys. The gradient represents the slope of this landscape at a particular point.
Okay, so the steeper the slope, the bigger the surprise.
Right, exactly.
Like stumbling across a hitter cliff when you thought you were on level ground.
Exactly. The steeper the gradient, the more unexpected the information is to the AI.
Okay.
And that triggers a stronger response, making it more likely that the AI will remember that information.
So it's like the AI is saying, whoa, I need to pay attention to this.
Precisely.
Okay.
And by fine-tuning the parameters that control how much surprise is needed to trigger long-term memory storage, the researchers can optimize the AI's learning process.
So they're finding that sweet spot between remembering everything and focusing on only the most important and unexpected stuff.
Exactly.
But wouldn't that lead to the AI overreacting to every little anomaly?
Right.
Like mistaking a random blip in the data for a groundbreaking discovery.
That's a great point, and the researchers have a clever solution for that.
Okay.
They use something called momentum. Yes, like a snowball rolling down a hill, getting bigger and faster as it goes.
Okay.
Perfect analogy.
Right.
In this case, the momentum refers to how much past surprise is carried over into the current calculations.
Okay.
So if the AI has been consistently surprised by a certain type of input, it will be more sensitive to similar inputs in the future.
So it's like the AI is building up anticipation based on its past experiences. It's not just reacting to isolated surprises.
Right.
It's looking for patterns and trends.
Exactly. And that helps prevent the AI from overreacting to those random blips you mentioned.
Okay.
Making sure that only the most persistent and meaningful information gets stored in long-term memory.
Wow. It's amazing how much thought and detail goes into designing these systems.
It is.
It's like we're taking inspiration from nature, from the way our own brains work, to create something truly extraordinary.
It's an incredible feat of engineering and a testament to human ingenuity.
But, you know, as we're talking about all these technical details, I can't help but think about the bigger picture.
Okay.
What does all this mean for the future of AI? Are we talking about a paradigm shift here?
I think we are.
Really?
Titans are challenging our fundamental assumptions about how AI can learn and process information. And they're paving the way for a new generation of AI systems that are more adaptable, more efficient, and perhaps even more human-like in their reasoning abilities.
It's both exhilarating and a little bit unnerving to think about, isn't it?
It is.
I mean, we're talking about machines that can learn, remember, and even reason like we do.
Yeah.
What does that mean for the future of humanity?
That's a profound question.
It is.
And honestly, I don't think anyone has a definitive answer.
Right.
But I believe it's up to us to shape that future. The potential is immense, but so are the challenges.
Right.
We need to approach these advancements with both a sense of wonder and a healthy dose of caution.
I couldn't agree more. It's a powerful reminder that while we're creating these incredible technologies, we also have a responsibility to guide their development and ensure they're used for good.
Absolutely. It's a shared responsibility
Right.
that requires open dialogue, thoughtful consideration,
Right.
and a commitment to ethical principles.
Well said. This has been an incredible deep dive into the world of Titans
It has.
and what they might mean for the future of AI.
Yeah.
It's a journey that's just beginning.
It is.
And I, for one, am excited to see where it leads.
Me too. It's a fascinating time to be alive, to witness these breakthroughs and ponder the possibilities they hold.
And on that note, we come to the end of another deep dive.
Okay.
Thanks for joining us on this exploration of the cutting edge of AI.
Yes.
Keep those brains curious, folks.
Until next time.